Okay, for today's homework, you are expected to complete questions 4, 5, and 6 from the Math Warm-Ups package. All right, let's talk a little bit about the expectations and practice a little, so hopefully your homework will make a little bit more sense to you today. On number 4, the concept that we're trying to work on here is determining whether an answer is reasonable based on fractional benchmarks. So in order to understand whether or not this model is correct, we have to know a little bit about the different fraction benchmarks between 0 and 1. And so what I like to think about is if you have a number line, one of the most important benchmarks on a number line is the starting point being 0. That's a benchmark. Most people know what 0 signifies and how much 0 is. The next important benchmark is the halfway point. The middle of this number line, it represents the halfway point. So it represents 1/2. This is an important fractional benchmark, as most people can show you what 1/2 looks like. If I were to tell you to fill a glass halfway, most of you would be able to do it. And then, of course, 1/2 is an important benchmark. Most people can tell me what 1 represents and how much it is. A couple of other new benchmarks would be, if we were to take this number line and divide it into 4 equal parts, this would be 1 equal part, 2 equal parts, 3 equal parts, 4 equal parts, then this first equal part would represent 1 of the 4 equal parts, or 1/4. Which means if this would be 1/4, then this second equal part would represent 2/4, meaning that 1/2 and 2/4 are equivalent to each other. Then the third equal part, this third equal part would represent 3/4, and this fourth equal part represents 4/4, or it means it's equivalent to 1 entire whole. So what we need to be thinking about, boys and girls, is when you're looking at this problem and trying to decide if this model is correct, you have to think about, look at the picture of the milk and the size of the rectangle. Does that look like a good representation of what 3/4 looks like? So look at my number line. Look where 3/4 goes all the way to. And then take a look at the oil. The oil says it's supposed to be 1/4 of a cup. Look at the size of that box. Look at where 1/4 falls on our number line. Is that box a good size representation of what 1/4 looks like? Especially when you compare it to 3/4. Look where 1/4 is on our number line, and look where 3/4 is. And you have to decide, is this model really a good representation of 3/4 cup of milk and 1/4 cup of oil, and explain whether it is or it isn't a good representation, and why. Okay. All right. On number 5, the standard that we need to be familiar with in order to solve this problem is comparing fractions. We're basically comparing these two girls in the problem, and we want to know which one of these shows a good, correct representation of the amount of homework the girls have completed. So the strategy we learned in class for comparing fractions is to use the butterfly method. So if I were to give you a problem such as 4/6, and I wanted you to compare it to, let's say, 6/8, we would do that by using something called the butterfly method, which means we're gonna multiply 4 and 8 to get a product of 32, and then we're gonna multiply 6 and 6, which gives us a product of 36. Because this product is greater than this product, that tells us that this fraction 6/8 is greater than 4/6. Okay. However, if I read this problem from left to right, I would say that 4/6 is less than 6/8. Okay. So you're going to have to be able to compare these two fractions to decide who had completed a greater amount of their homework. So that's number 5. On number 6, we have to use our knowledge about equivalent fractions. So we spent a great deal of time generating equivalent fractions using pictures, dividing, using multiplication, and so we know how to generate equivalent fractions. Now we have to learn how to interpret that information to make a decision about what's true about 5/10 and 6/12. So let me give you an example. If I were to give you 4/8 and let's say 8/16, okay, I know that if I have 4 out of 8 of something, I don't have all of it. 4 out of 8 is actually equal to a half of something. So if I had a rectangle and I cut it into 8 equal parts and I shaded 4 of them, I've only shaded half of that. I haven't shaded the whole thing. So I know that this 4/8 is actually less than 1 whole. Because if I have 4/8, I'm going to go ahead and divide, make a representation of this. So here's 8ths. If I shade in 4 of them, I have not shaded the whole thing. So I know that this 4/8 has to be less than a whole. And then same thing with 8/16. If I make a rectangle of 16 equal parts and shade in 8 of them, I have not shaded all of the 16 equal parts. Therefore, I do not have a whole. This represents less than a whole as well. So we know they're less than a whole, but we also know they're not greater than a whole either. They're not greater than a whole because 4 out of 8, shading in 4 of these is less than a whole. And if it's less than a whole, then obviously it can't be greater than the whole thing. So we know that both of these fractions are neither greater than a whole or less than a whole. But what I do know is that in this fraction, this 8 is twice the amount of this 4, and this 16 is twice the amount of 8. In other words, if I double the number 4, 4 and 4 make 8. If I double the number 8, 8 and 8 make 16. So I can generate equivalent fractions based on this knowledge. I know that 4 can go into 8. So what I'm going to do is I'm going to divide that 4 by itself, and I'm going to divide this 8 by 4 also, because whatever you do to the numerator has to be done to the denominator. And I generate an equivalent, a fraction of 1. 4 divided by 4 is 1. 8 divided by 4 is 2. I generate a fraction of 1/2. So this 4/8 is equivalent to 1/2. Okay? I can do the same thing over here. I know that 8 can go into 16 twice. So I'm going to take this 8 and I'm going to divide it by 8. And of course, whatever I do to the numerator has to be done to the denominator, the bottom number. So I'm going to take 16 and divide it by 8. And if I divide 8 by 8, I get 1. And if I divide 16 divided by 8, I get 2. So 8/16 is equal to 1/2. So what I have discovered is that if 4/8 equals 1/2 and 8/16 equals 1/2, then this 4/8 must also be equivalent to 8/16. They are equal to each other. Okay? And so part of me knowing that is because the denominator is twice as much as the numerator. It's double the amount of the numerator. So let's see if you can take what we talked about here and apply that to answering question number 6 when you're trying to decide which one of these statements is true. All right, I hope this helps. Good luck, guys. Thanks for working so hard on your homework.